4 years ago, NASA launched the James Webb Space Telescope on a mission to explore the earliest days of the universe. We built a telescope powerful enough to see back toward the Big Bang. The James Webb Space Telescope began an incredible journey through deep time, helping scientists understand how stars, planets, and galaxies are born, how they evolve, and what happens when they die. And in just a few years, Webb has already delivered some of the most breathtaking images humanity has ever seen. These are the greatest discoveries the James Webb Space Telescope has made so far. This is the Sombrero Galaxy. Visible light images only reveal the galaxy's bright central core, but Webb's mid-infrared instruments uncovered something completely different. A smooth inner disk surrounded by intricate clumps of dust in the outer ring. It still doesn't really look like a hat to me, but it does look incredible. Astronomers also discovered an extremely hungry black hole at the center of a dwarf galaxy from the early universe, dating back roughly 1.5 billion years after the Big Bang. Using Webb's data, researchers found that this supermassive black hole is consuming matter over 40 times faster than scientists thought was possible. That feeding frenzy is probably short-lived, but it may explain how supermassive black holes grew so rapidly in the early universe. Webb and the Hubble Space Telescope teamed up to capture this unprecedented image of Vega, one of the brightest stars in Earth's night sky. Hubble revealed a vast, smooth disk of fine dust, while Webb's infrared vision detected warm, glowing dust farther out. Oddly enough, the disk appears to lack the clumps of gas usually linked to giant planets. So Vega might just be floating out there alone, surrounded by rocks. This stunning composite image combines Webb's infrared observations with Hubble's ultraviolet and visible light data, revealing two spiral galaxies in the middle of a cosmic collision. The vivid colors highlight enormous clouds of gas and dust, the raw ingredients needed to create new stars. When these galaxies pass through each other, gravity completely reshapes them. Their spiral arms stretch, twist, and collapse into massive waves of gas, triggering huge bursts of star formation across both galaxies. Some of the brightest regions are actually stellar nurseries, where thousands of new stars are being born at the same time. Over millions of years, encounters like this can completely transform galaxies. The violent interaction can funnel gas toward their centers, potentially feeding supermassive black holes and creating incredibly energetic galactic cores. Eventually, these two spirals may merge into a single larger galaxy, forever changing their structure. This object is Centaur 29P, a giant ball of rock and ice orbiting between Jupiter and Neptune. And what Webb captured here is basically a giant asteroid fart. Using its near-infrared spectrograph, Webb detected massive jets of carbon dioxide and carbon monoxide blasting from the object's surface. Here we have a strange galaxy from about 1 billion years after the Big Bang. What makes it unusual is that its gas shines brighter than its stars, something astronomers almost never see. Researchers believe this galaxy may represent a transitional phase between the universe's first primitive stars and more mature galaxies. This pair of galaxies, located 465 million light-years away in the constellation Leo, are crashing directly into each other. One is a spiral galaxy, the other is elliptical, and the spiral's arms are being violently stretched and distorted by the immense gravitational forces of its companion. Webb also explored the outermost edge of the Milky Way, a region known as the extreme outer galaxy. Using its near and mid-infrared instruments, the telescope captured stunning star-forming regions hidden inside enormous molecular clouds. The observations revealed young, massive stars, along with incredibly detailed structures of gas and dust at the edge of our galaxy. And then there's this, a galaxy shaped like a giant cosmic question mark. This bizarre structure is caused by gravitational lensing, where the gravity of a massive galaxy cluster bends and magnifies light from a much more distant galaxy behind it. One of Webb's earliest discoveries shocked astronomers. The telescope found gigantic, ultra-bright galaxies existing just 500 to 700 million years after the Big Bang, far earlier than expected. At first, these galaxies seemed impossibly large for their age. But newer research suggests that rapidly growing supermassive black holes at their centers may have made them appear brighter and more massive than they really were. This is a gas giant exoplanet, several times the mass of Jupiter, located about 12 light-years away from Earth. Its temperature is estimated to be around 35 degrees Fahrenheit, making it one of the coldest exoplanets ever directly observed. Not because colder planets don't exist, but because we can finally see worlds that aren't blazing hot stars. And honestly, that's pretty cool. This exoplanet has one side locked in permanent sunrise, and the other in eternal sunset. Using Webb's near-infrared spectrograph, astronomers discovered a temperature difference of roughly 300 degrees between the two sides. You'd probably assume the sunrise side would be hotter, but surprisingly, the sunset side is actually the warmest. To celebrate its second anniversary, Webb captured this stunning image of two interacting galaxies, nicknamed the Penguin and the Egg. Located 326 million light-years away, the pair began colliding somewhere between 25 and 75 million years ago. The interaction stretched one galaxy's spiral arms into a shape that eerily resembles a penguin protecting an egg. This is a protostar, essentially a baby star before nuclear fusion fully begins. The bright hourglass-shaped structure comes from powerful outflows slamming into surrounding gas and dust. A dark, thin disk cuts through the center, feeding material into the growing star. Webb also captured this extraordinary image of the Serpens Nebula, revealing multiple pairs of bipolar jets blasting from newly forming stars. The jets align closely with surrounding gas filaments, supporting theories that magnetic fields play a major role in shaping star formation. The Crab Nebula is basically the aftermath of a stellar explosion. Located 6,500 light-years away in the constellation Taurus, this supernova remnant was imaged in stunning detail by Webb's infrared instruments. The telescope revealed intricate filaments of gas and dust, along with regions where entirely new stars may eventually form. These are twin baby stars formed only 2 to 4 million years ago. Webb's mid-infrared instrument even detected jets of gas erupting from both stars simultaneously. These three galaxies are among the oldest ever discovered, dating back only 400 to 600 million years after the Big Bang. And somehow, they're still actively forming stars. They do this by pulling in enormous amounts of cold hydrogen and helium gas from their surroundings. Webb also studied WASP-107b, a bizarre marshmallow planet with an incredibly puffy atmosphere. Scientists discovered a surprising lack of methane, suggesting the planet's interior is far hotter and its core much more massive than previously believed. One exoplanet, located 280 light-years away, experiences wind speeds reaching nearly 8,000 kilometers per hour. Because one side constantly faces its star while the other remains in darkness, the planet experiences extreme temperature differences that drive terrifyingly fast atmospheric winds. This is the sharpest infrared image ever captured of the Horsehead Nebula. I still don't really see a horse, but Webb revealed incredibly detailed interactions between gas and dust inside the nebula's famous structure. This galaxy, located 12 million light-years away in Ursa Major, is known as a starburst galaxy. It forms stars at a rate nearly 10 times faster than the Milky Way. Webb also detected complex organic molecules, including alcohol, frozen inside a molecular cloud. These ingredients may have existed during the earliest stages of planet formation and could help explain how life-supporting environments emerge. This massive star-forming region inside the Triangulum galaxy contains more than 200 young massive stars in the earliest stages of development. Webb observed one of the brightest and most distant galaxies ever discovered, existing just 430 million years after the Big Bang. Researchers using Webb discovered that many early galaxies don't look like spirals at all. Instead, they resemble pool noodles and surfboards, which honestly feels scientifically disrespectful. Webb also detected an aurora glowing above the North Pole of a solitary brown dwarf located 65 light-years away. Unlike Earth's northern lights, this aurora isn't powered by a nearby star. Instead, it's likely created by the brown dwarf's own magnetic field interacting with charged gas in space. This haunting image shows the aftermath of a supernova explosion. Webb's infrared vision revealed expanding clouds rich in sulfur, oxygen, argon, and neon, the very elements that eventually become part of new stars, planets, and maybe even life itself. This glowing structure is called a Herbig-Haro object. These objects form when jets from newborn stars slam into surrounding gas and dust at incredible speeds, creating violent shock waves that light up space. Webb also unveiled an astonishing new view of the center of the Milky Way. Its instruments captured nearly 500,000 stars, along with mysterious blue, needle-like structures scientists still don't fully understand. Another Webb and Hubble collaboration produced this spectacular image of a massive galaxy cluster. By combining infrared and visible light observations, scientists created a panoramic view stretching across wavelengths the human eye can barely comprehend. Webb even discovered a previously unknown jet stream in Jupiter's atmosphere. The stream spans over 4,800 kilometers and reaches wind speeds above 500 kilometers per hour, high above the planet's cloud tops. And on Jupiter's moon Europa, Webb detected carbon dioxide frozen on the surface. Scientists believe the carbon may have originated from Europa's hidden subsurface ocean, an exciting clue in the search for life. This is Arundel, the most distant individual star ever detected. Its light traveled for billions of years from a galaxy located roughly 28 billion light-years away. Webb identified it as a massive blue star over 1 million times brighter than our Sun. And we can only see it because gravity itself magnified the light like a cosmic lens. This gigantic galaxy cluster, nicknamed El Gordo, acts as one of the universe's most powerful natural magnifying glasses. Its immense gravity bends and stretches light from galaxies hiding far behind it. Webb also observed another Herbig-Haro object, produced by two actively forming stars, ejecting material in opposite directions for thousands of years. The resulting shock waves create these stunning glowing colors. For the first time ever, Webb detected water vapor inside the habitable region of a distant solar system, the exact zone where rocky planets like Earth could potentially form. To celebrate its first anniversary, Webb captured this incredible image of the closest star-forming region to Earth. The image revealed countless protostars firing energetic jets through surrounding clouds of gas. Webb also discovered two extremely dusty supernovas, supporting the idea that exploding stars played a major role in filling early galaxies with cosmic dust. The telescope even uncovered a massive cosmic web made of 10 interconnected galaxies dating back just 830 million years after the Big Bang. This enormous structure provides insight into how gravity shaped the large-scale universe we see today. This barred spiral galaxy, located about 20 million light-years away, contains a bright central bar funneling gas inward and fueling intense star formation. Webb detected a gigantic plume of water vapor erupting from Saturn's moon Enceladus. The plume stretches nearly 10,000 kilometers into space, over 20 times larger than the moon itself. Webb also captured an unprecedented view of a mini-Neptune exoplanet roughly 40 light-years away. Its reflective atmosphere appears filled with thick clouds, haze, and significant amounts of water vapor. This ultra-luminous infrared galaxy was created by the collision of two spiral galaxies. The merger triggered an enormous burst of star formation, creating around 200 massive star clusters in a relatively tiny region of space. Webb captured astonishing new details of Cassiopeia A, the youngest known supernova remnant in the Milky Way. The images revealed bright knots of material and intricate expanding debris fields left behind by the stellar explosion. The telescope also measured the dayside temperature of TRAPPIST-1b, a rocky exoplanet about 40 light-years away. The surface reaches roughly 232 degrees Celsius, suggesting the planet likely lacks a substantial atmosphere. This star is basically a ticking time bomb. Wolf-Rayet stars are massive, unstable, and incredibly short-lived, destined to explode in catastrophic supernovas. This deep-field image of Pandora's cluster reveals three giant galaxy clusters merging into a colossal megacluster. The combined gravity creates an enormous gravitational lens, allowing astronomers to peer even deeper into the universe. And yes, Webb can even see relatively small asteroids in our own solar system, like this one, which is comforting and terrifying at the same time, because some of those rocks could absolutely wipe out a city someday. This dusty disk was left behind after planets collided. Webb captured the clearest infrared view ever obtained of the debris surrounding the impact zone. Inside the small Magellanic Cloud, Webb revealed a chaotic star-forming region filled with hydrogen and dust, the raw materials needed to build entirely new solar systems. In the famous cosmic cliffs of the Carina Nebula, Webb uncovered previously hidden jets and outflows from young stars buried deep inside the clouds. Webb also revealed the bizarre structure of the Southern Ring Nebula, which may have been shaped by not one, but multiple hidden companion stars interacting over time. Then there's this haunting infrared image of the pillars of creation. Unlike visible light photos, Webb's infrared instruments pierce through the dust, exposing the complex structures hidden inside. Astronomers also discovered a cluster of massive galaxies forming around an extremely red quasar from 11.5 billion years ago. The finding offers clues about how the earliest galaxy clusters assembled themselves across the cosmic web. And finally, this may be one of Webb's strangest images yet. At least 17 perfectly spaced dust rings surrounding a binary star system. Every 8 years, the stars swing close together in their elliptical orbit, causing their stellar winds to collide and create expanding shells of dust. The result looks almost like the rings of a tree trunk, recording cosmic history one orbit at a time. And after only a few years in space, the James Webb Space Telescope has already transformed our understanding of the universe. It has shown us galaxies older than we thought possible, planets we never imagined we could see, and structures so massive and ancient they challenge everything we thought we knew about cosmic evolution. And the craziest part? Webb is only getting started.